right, everybody. Thank you so much for joining us today for Data Bytes. We're super excited. I'm really not the purpose for the show, so I'm going to keep this very short. But I did want to make sure we say thank you. I wanted to do a huge thank you over to the Arize team. Super appreciative of Sarah and John for being here and all their help. Excited to be diving into all things related to great AI tooling and how you can think about things from ingestion to observability and so on. That said, the way we're going to be doing today, you're going to be hearing from each of our speakers. We'll do Natik first to talk more of what we're up to here at Airbyte. He'll answer some questions at the end of his portion, but then we're going to also pass it over to John to do his presentation. Same thing. He'll answer some more questions. At the end, if we have a lot more time, we'll also continue to open more questions, but we want to give you the opportunity to continue mingling. So you'll have the presentations. Any leftovers that are still there will be there, so no stress. And if they're not there, you can say, Teo, the doorman, lied to me. But again, just thank you so much for coming. Passing it over to Natik.
Hello? Justin told me I have to speak into this thing, so bear with me. So the formal part is going to be relatively short. I want to talk to you about getting your data ready as the first step of applying whatever you do in your AI applications. And my main point, moving data should be a solved problem, right? In software, oh, you're scraping an API. Well, there must be a library for that. It must be a solved problem. And so I joined Airbyte 9 months ago. And when I talked with my boss about joining, I thought, what do you mean you're moving data? It's a solved problem. So I learned a few things, and I wanted to share with you what I learned about what we do here at Airbyte. What are some of the things that we've figured out in the last year and a half about our extensibility engine, connector builder, and how we do low-code connectors and long tail of connectors, supporting any API sources you need, and how it all works together today, and how you can make connectors relatively quickly, hopefully within 10 minutes, and how you can hash some of your data so you get safe, secure data into your AI models. All right, let's go. So, we've shipped the first version of the thing called Connector Builder in early 2023. I think the first public commit was like November 2022, where the framework, the local framework itself was released. But the builder arrived in 2023. So let's take a look at how we're doing. I hope these are OK to share, and I'm not going to nuke myself out of the company by breaching the NDA. But we have a lot of workspaces, 25,000 live connections across Airbyte installations, 10,000 builder connectors, 4,000 workspaces using them actively. And the last number, 316, are the connectors just on cloud that are such that they connect to the same domain. So like 316 domains, 316 API applications that people are syncing data from. They're either not present in our catalog yet, that's a miss on our site, or people added streams, fixed box in our catalog connectors, and made their own. And, at times, it was nice and super easy to use, and at times it was challenging, I have to admit. Now, one thing I wasn't sold at initially is, well, you have a low-code framework, that's nice, but low-code frameworks have a little problem. The second you need something custom, what do you do, and what are your customization options, and are we just doing Jinja interpolations? That's it. And now we support customizations at any level of abstraction of your connector. You can have fully custom connector that still has a YAML manifest that's saying, hey, I'm a connector, I'm doing this thing, syncing data from the API. Or you can have custom streams, or you have custom decoders. This chunk here is the first one that was on my way in my editor. It's an amplitude. They have deeply nested structure of records in the responses, and this custom component basically says, oh, okay, I got this bunch of JSON, let me parse it real quick. And then, okay, another thing, you're all software engineers, data engineers. You don't necessarily want a big graphic user interface tool that requires Kubernetes to run. Can you do it in Python in 10 minutes? Well, yeah, you can run the same connectors in Python. Going back to nice demo that Aaron did back in April, we have a thing called Airbyte. You can pip install Airbyte and then run the script that's super similar to this. We're going to run one of those, and it works. And the nice part about this is you don't have to throw it away when you're done. You can prototype and then use it in Web Airbyte as well. The other big thing we did is we shipped a thing called Connector Marketplace as opposed to Catalog. The difference, we clearly delineate connectors that we've built in-house and we support in-house, and connectors that other people in Marketplace built. And our goal was to communicate, do they actually work? What streams work? What streams are proven to be successful? And how many people are using them? So we're showing these little usage indicators on them and success rate indicators on them. And lastly, I love open source. I got here, I worked on a few developer tools before, but I spent a good half a year figuring out what I want, what niche I want, what company type I want. And Airbyte, being a young company, had a few challenges of establishing open source beyond that just being a marketing gimmick, actually supporting our community and getting high quality software out of it. So there's a bunch of things. How can we, can we be really confident that those open source contributions work, 6 months after a contribution, a year after a contribution? How can we provide bug fixes? How can we accept new contributions quickly without review process taking a good month? And so on and so on. And we found questions to them. We're now posting public quality indicators. We have clarity and prioritization of open source issues, and we have community engineers that are engaged with us, and they're constantly fixing some of the issues that show up. And our review times are now down to under 1 workday. Like the last connector that we've accepted, I think the PR was on Friday, and we merged it today. Close enough. And if anything in the marketplace doesn't work, soon you will be able to just fork the connector, open it in your connector builder, not starting from scratch, but starting from a connector in a marketplace. So we are merging 2 big things. Previously, there was the marketplace, and you could create a custom connector in Airbyte. What we're doing is we're changing the format of the connectors that we have in the catalog to what we call manifest only, and meaning you can now open them, soon we'll be able to open them in Builder itself. Right now, out of our 300-ish sources, 138 are already manifest only. And making a manifest only connector is super quick and easy. You can make one, 15 minutes, 30 minutes if it's a bit more complex. Pretty much the same time that you would spend in a Python script, unless you're using LLMs, but don't cheat. So, surely if I try to do a live demo, everything's going to work, right? Let me try. What we're going to try and do is we're going to make a connector. Now, I was thinking about what connectors to do, and I realized, well, we all used a little piece of software called Luma that we used to sign up for this meetup. And let's build one. I'm going to try and do it real quick. Questionable, I'll try. All right. Font size. Better? All right, I'm going to cheat a little bit because I need their URL host. Okay. So, to make a connector, we need the base URL. That's the first thing. And the other thing that we need is we will definitely need an API token. Now, I'm not going to show you my token. I'm going to copy it from my phone. Bear with me. And let me take a look real quick. Here it's like, OK, excellent API key. Imagine I just looked at the docs. All right, now we will stream our first bunch of data, and let's first grab the list of events. And I think it's, let me take a look here. OK. Calendar list events. Great. Now, let's just run the request real quick, see what's getting out of there. And we got something. We got a bunch of things. So first things first, let's figure out where is the data that we need. And it is in entries. And then there's the array. And inside of that, we need the thing called the event. OK. And the primary key is this. OK. And then if we scroll a bit, we have this has more flag in the body. And I think it's for pagination. It's probably cursor. And where is it? It's probably next page. Cursor, but I'm going to verify. Whoop, whoop, whoop. I like to. OK. And what was here? OK, query parameter. What was that? OK, pagination cursor. All right, so this should give us the list of events. And I got 8 records. That's consistent. I'm using the key that we are using. And we've hosted or planned 8 meetups. Nice. Now, let me save us all a little bit of time and show you the next stream that we're going to do. And this stream is called Guests. I want to know something about all of you, and we're going to use this URL. But the little thing here is that I'm using, oh my god, this page size. I'm using a parent stream because guests are substream of events. And so I'm defining the parent key of API ID on the events. I'm saying that it's going to be event API ID on the parents. And when I run this, I'm going to get a bunch of data. That's going to take a second. Nice. Now, a little problem here is that I'm going to also get information about people that I don't want to keep here, such as, oh, Teo's email is fine. Like their emails and their names and their phone numbers. We don't want those. Imagine their social security numbers. This thing shouldn't touch your Snowflake, or your security people is going to be really mad. So we have transformations, and we're going to just hash the email, hash the phone number, and then delete them. Make sure that these things don't hit your data lake ever. And if we look at the records, I believe that the event that we are at is event number 7. Pardon me, this thing was not designed for Zoom. And yep, we have signups around yesterday. You should recognize some of yourselves. Sorry about leaking names, but I'm at least not leaking emails. All right, so the next little thing is, I promised that this works in Python, right? So I exported this connector into this file. Now, yeah, this thing is just grabbed from the builder, export button. And this little script is completely copy and pasted from Airbyte getting started. I was confused, so hence the name. And what we're doing here is we're reading the manifest file, putting it in a dictionary, and then instantiating the source. Woo! Setting up my config key. Now, Teo, I gotta rotate that. And and now I can run that. And it's going to scream at me a little bit, and hopefully not process records because they're cached. You can believe me, or we can actually sync them. Yep, here's our stuff, syncing up. Now, the pinnacle of engineering here at Airbyte is that almost everything went smoothly. And we did a lot of stuff. We just created a new source. Granted, it has 2 streams, but it also has data transforms, and we cleaned up our data. We ran it in Airbyte, and now we're going to contribute it to GitHub. This is going to involve me copying another token. And that one I don't want to leak because it's from GitHub. wants my security key. One second. Let's see if. Okay, I think I'm good. 1 second. Regenerate. Copy. Okay, so for this, we're going to go to our connector that we just ran, and we're going to click Contribute. We're going to call it source Luma, and we're going to give it my GitHub token, and we're going to click Contribute. Now, 3 out of 3 would be really lucky. Huh? Yay. So the connector now is basically the manifest file, the metadata file, and the icon that we should really upload. And hopefully by the time we're done with pizza leftovers, this gets merged. And I have one more connector. Now, that's how easy it is for you to get your data in. We're going to talk more about what you can do with that data with John and Sarah. Thank you for sitting through us. Now, if you've tried using Airbyte and got problems or confused or want to consider doing your own connector, talk to me. If you have a little software as a service company and you want your users to be able to export data, let's make it happen. There's still some pizza and maybe even beer. Also, hiring Python and JavaScript engineers, talk to me. That's all I got.
That was cool. Well, you did a lot of typing. I wonder when will the LLM guess all of the fields that you had to.
Have you seen this little button? OK, so the question was, that involved quite a lot of typing. Can we do that? I said, hey, you can do this faster than you can do the Python script, unless you're using an LLM. Can you use an LLM in Builder? The answer is yes, you can. It's closed beta. It's going to be released it's released internally this week, maybe next week for community members, influencers. Reach out. We're playing around with it. It has very decent success rate, and we're still improving it. And it's Copilot style. So when this thing is on, you will see that a lot of fields have this little thing that says, hey, I can suggest things. And sometimes it suggests things very nicely. And sometimes it's just wrong. So, trade-offs. We're tuning it. That's it? All right. John's turn.
We'll be around if you have more questions later. Before John goes, quick question. Where's Valentin? Valentin, I got an ID over here for somebody. Oh, that means we've lost somebody without their ID. There we go. Can you pass me this? Thank you. John, off to you.
All right. Let me get set up. Hello, everybody. How's it going? You guys will see that? Awesome. OK, before I kind of jump into everything, I want to get a better sense of who's all in the room. So if you are an AI engineer, raise your hand. OK. If you're a data scientist using AI in some way, raise your hand. OK. And then if you've never built anything with AI, but just are a big fan. Cool. I see you in the back, Tao. Thank you. Awesome. OK. And has anyone used Arize or seen Arize or Phoenix before? OK. Cool. I see a few hands. That's awesome. Okay, cool. That helps me get a sense of kind of what everybody knows and how deep we want to go. My name is John. I'm a developer advocate here for Arize. And I have a pretty ambitious thing we're going to go through here, which is basically we're going to show the process of kind of taking an agent that we've built. We're going to use a LangGraph agent and kind of go through and add in evaluation, tracing, and some experimentation to it to kind of give you a full picture of what that all looks like. So I'm going to jump into that in a second. But let me start with a little bit of background on Arize, kind of who we are, what we do, that sort of thing, just to kind of level set everything before we jump into the technical kind of walkthrough. I'm going to be deep in the code after that, so we'll start with that. So yeah, just start off with, for the AI engineers, the folks who played around with it, let me know if this looks familiar. Also, can you guys see this, or am I blocking it? I see some, cool, all right. So for the AI engineers in the room, let me know if this looks familiar. You've built some sort of application, you've got an MVP going, it works, it's like everything's great, and then you decide to try to fix like one other area, you tweak your prompt, you switch out your model, and then everything breaks, and like you start getting junk responses in a bunch of places. I see some nods, so I'm gonna take that as yes. This is the kind of thing that we are trying to remediate with Arize. We're really trying to prevent these sorts of things, but the downside is this has kind of been the reality of AI engineering for the past few years, is you're kind of playing whack-a-mole with different errors and issues that come up as you try to make the whole pipeline work. So those are the kinds of pain points that we try to see and try to fix with Arize. So we see everything from early in development, a big lack of visibility into what your application is doing. We'll see this throughout as we go into the technical example, but you have these amazing frameworks like LangChain, Llama Index, all these other tools that make it really easy to stand up MVPs. But then you end up with a situation where like one line of code is actually calling 12 different things in the background that you don't know about. And that's, if anything breaks along those lines, it's very hard to see what's going on. So that lack of visibility early on is something that we definitely want to help with. And then as you get into an application that's working, that's where we start to see issues with how do you evaluate and improve and kind of take your application from an MVP that's working in some use cases to something that's more robust, working across a bunch of different use cases. So Arize tries to help with all of these different areas. We're going to focus more today on the traces and evaluation, kind of the first two rows that you see here. Part of that comes from the fact that everything I'm going to show you today is possible with our open source platform. So we're not going to use anything from an enterprise product, which Arize does have. We're going to use all the open source stuff. But if anyone's curious afterwards, I'm happy to go into more of the detail on the kind of next two rows, like your guardrails, online evals, some of the stuff that you see down below there as well too. And I mentioned we're going to use the open source tool. So the open source tool I mentioned, it's called Phoenix. That's our open source project that we support at Arize. We really want to make sure that we're contributing to the open source space. And so that's something where we want to make sure we go into detail there. And yeah, I think that basically covers what we're going to cover on the slide. Okay, cool. So with that, I want to jump into the actual kind of walkthrough that we have here for the agent. I mentioned that what we're going to use is we are going to have an agent that we've built that it comes equipped with a couple skills. It can call out to a RAG pipeline that we have that asks the questions over Phoenix documentation. It can search the web using a Tavily search skill that we have. And we're going to use a bunch of tools to do this. This is the AI Dev Tools meetup after all. So we're going to use a lot of different tools across the board here. So we're going to use Phoenix, we're going to use Airbyte, we're going to use Pinecone, LangGraph, Apify, and Tavily. I promise it's not going to be that hard to sort of parse through as we go through. So this is the agent that we're going to use. I'm not going to go into too much detail on like building the agent, but I'm happy to share the notebook or kind of go into the code as well with folks afterwards, just for the sake of time. But before we can even get to building the agent, we have to kind of set up the data pipeline that we're going to use. And so that's where Airbyte comes into play. So with the data pipeline that we have, I mentioned that one of the skills is going to be this RAG agent that we want to use, or RAG kind of skill that we want to use. And so for that, we want to be able to ask questions about the Phoenix documentation. So we need to get the Phoenix documentation into a vector database that we can use and set that up in a way that makes sense and works. So the way that we've decided to do this is we're going to use Apify plus Airbyte plus Pinecone. And luckily, before this, Airbyte made this very easy for me to do. Let me increase that. So what I've done to actually power this is I've used a connector from the marketplace, actually. So bonus points for that side of things, which is cool. It works. It was an Apify connector from the marketplace. And so we've set up a source here, which is Apify. If anyone hasn't used it, it's a very easy way to kind of scrape web URLs and scrape web pages. And so I basically had Appify go through, scrape a bunch of stuff from our Phoenix documentation, set it up in this little database here. Cost me 41 cents to do. Very easy. And then set it up in Airbyte to actually go through, set that up as a source, and connect it through to my Pinecone instance. So I have a little connection here that combines these two things, passes over a few data points from a few data points from our crawled web docs. We have the text and the documents. So I have that all set up here. And now that gives me my Pinecone database that I can actually use. And that really takes care of the sort of bottom piece of this that we have of our data pipeline, sending that in so we can use it from our agent. So at that point, we're ready to go and actually do the agent from there. So let me jump over to the code. And I mentioned there's a ton in here. I got kind of ambitious with this whole project, so I want to make sure that I'm not boring everybody. So I won't go into tons of detail on the LangGraph side of things. But again, if you want to go through that, come find me afterwards. But basically what we've set up here is we've got a LangGraph agent. Yeah? Oh, yep. I knew I was going to block something.
Thank you.
There we go. Can you see that a little bit better? Okay, perfect. So we have a LangGraph agent. We've set up a tool that is calling to Phoenix. And again, can share this afterwards or go through in more detail. This is a lot of kind of boilerplate LangGraph code that we use to set up a little agent. And then this is kind of helpful to see. You know, I'm going to do this actually. That's what our agent looks like at the end. So we have a nice little start that goes to our assistant. We have an assistant that can call out to some tools. Those two ones I mentioned, the web search tool and then the RAG tool that we have connected to Phoenix Docs. It'll loop back and forth between those steps until it answers the user's question and then pass it out to the end state. So with that, if I actually go, I'm just going to quickly wrap this thing in a Gradio interface that we can use. And we've got a little chatbot that we can use here. So this is me one part I have to put on the mic for. So let me ask it a quick question. He's also a developer advocate, so he knows the pain that comes. He's just got my back here over here. But yeah, so this is going to go through, generate a response. It can tell me about Phoenix evals, pulls that information. And so we've built our MVP. We've got this working. The question is, what do we do with this now? How do we improve this? How do we make it better? How do we see what's going on? And so I would argue the first step that we want to do is we want to get more info into what's actually happening when this thing is going and making its calls. Because I showed you the diagram, but we don't actually know exactly where that's going. So ignore those warnings. Those are not important. We're going to go through here. And this piece of code that we have here is actually going to go and enable Phoenix to trace the application. So this is connecting Phoenix through to that agent that we just set up. And then it's telling it to basically pay attention to and track all of the calls that get made to LangChain. So with these few calls here, I've now got that set up to send information through to Phoenix. And if I go back to our chatbot, and it's okay, this will take me 2 seconds to type. And so now, if I type in this question, let's just open this in our web browser. I've got a cloud instance of Phoenix that's been set up here. This looks all right so far. And so I've got a cloud instance over here that we're connected to. And if I refresh this, of course, there's going to be some live demo thing that doesn't like me. I can go into here. I think this is the one we're connected to. Oh, no. You got all the live demo luck in the last one here. Okay, so here we go. So we were connected into here. We can see we've got now this trace that's been captured. And so this goes to what I was saying earlier. Let me just blow this up a little bit. That was like one call to our agent, and then it creates all of these traces, all of these method calls that are going through. And so you can see there's a ton that ends up happening here behind the scenes that we wouldn't really even know about if we didn't have some way of like looking at the calls that are actually being made. So I won't go through this in too much detail, but you can kind of see the blue sort of squares here are the logic steps that happen in LangGraph. We can see as it moves between nodes, what's happening, how it's making those decisions. And then we have the orange ones, which are kind of our calls to an LLM at that point. And so there's a call out to a GPT model that we can use to generate some sort of response. So in this first one, it's actually having it go to that first step of the agent, go through, generate what it should do as its next step. So it, in this case, if we actually go into here, it It has a bunch of tools that get passed in, so it can choose which tool to use from there. We can see all the stuff that's actually happening within that as we go through. And so it comes back, it actually recommends that we call both of these tools here. So it calls our RAG tool as well as our web search tool, which is kind of strange. I'm not entirely sure why it's having us do that. And then as you go further on, you get into the tool node that gets called here, and you can see it's calling out to both of our different tools. So I can even go in here and I can look at, okay, I've got the input and output of our retrieval step. I've got this retriever kind of stage here where I can actually see all the documents that are being pulled back as part of that step, and then all that kind of going back through into our system here. You can look at the Tavily piece, and then eventually you end up with a final LLM call where all of those responses are passed into an LLM to generate a final response to our user. So we have way more idea of what's actually going on underneath the hood as opposed to before, where we just get that response from a user. So that's all good and great, but you aren't really going to go through and kind of look in detail at every one of these traces when you have an application with multiple responses coming back. So this is where evaluation becomes more important. So what I can do next here is I can actually go and I can start evaluating these different calls and traces for our chatbot here by basically pulling out information from Phoenix and pulling out things from our database, running some sort of evaluation on that information to generate labels for it, and pass it back up into Phoenix. And so what I can do there, we'll see if this is going to be more helpful for me. Okay, that looks like it's actually working. There we go. Okay, of course not. Okay. You know what? I'm already running long on time, so I'm going to go into the dashboard and show you guys in here. So what we can do is we can pull out the information from Phoenix, generate labels over it using evaluations, pass those back up into Phoenix. And what we'll end up with is we have these kinds of labels that you can see here on the feedback side. So in this case, I evaluated them for hallucinations as well as for QA correctness. So ran that through, passed that back up, and I can automatically attach these sorts of labels to our individual spans. I can actually go in here and see, as we evaluate them, it actually gives us a response as well, too, of how it made that particular decision. So in the QA correctness piece, for example, this is showing us, okay, why is this actually incorrect? Not just that it's incorrect, but why is this incorrect, for example? And so this allows us to kind of sort of at scale pick and choose which kind of spans and which kind of traces we want to dive into, help us figure out exactly where the issues are in the application. Finally, from there, we could take this further and start experimenting with it and kind of go into more detail there. I think I'm already running a little bit long on our time. So in this case, I will save the experimentation for walkthrough for a later time. But the kind of final step of this is not just figuring out exactly where your issues are, but being able to jump into how to actually improve those from there. So one other thing that we can do is we can actually take the case that we ran here with our agent, and we can go and run it through an experimentation with kind of a base set of test cases, measure the evaluations on those, make changes to our model, and end up with kind of evaluation or experiment results like you see here, if this is big enough for people to see, where we can actually go and we can make modifications to our pipeline, view the results side by side as we go through different evaluations that we go through there. I can jump into these. You can see the evaluation results that we have as we run through a set of kind of test cases here on the far left side that I'm blocking. But yeah. So the idea here is that we can kind of give this full loop of not just giving you insight into what's happening in the application, but from there allow you to kind of evaluate the different pieces and calls within your application, and then finally start to make these kind of experimental changes to it to improve it over time, and ultimately see some of those scores improving and kind of give you the peace of mind that your application is working well in production or ready to be moved over into production. And so with that, I will open it back up to any kind of questions that folks want to go through.
I have a question.
Yeah.
Sorry, the previous screen.
Yep.
What is the capital of France? I felt like I was losing what's happening there.
Yeah, it's doing something wrong over here. So this would give us, this is one of the areas where we can kind of use some of the evaluations to point to it. I think what's happened here, and actually this is a great case, let me pull this open and we can see what's going on inside that particular trace. So let's see what it pulled out. So it looks like it pulled out some strange sort of document here that's not actually part of our data set that we used. So this would actually point us to something where we can go into that vector database that we have and figure out what does this extra thing come from at that point? Where is this extra thing? I think if I'm recognizing this right, this looks like a Paul Graham extract, maybe. So got some wires crossed or something there, but this is exactly the kind of thing we can see, okay, this gets caught by our hallucination or our QA correctness eval, or maybe a relevancy one or something like that we've set up, and then it can actually, we can kind of have that insight into what's happening, versus if we just look at the actual response, like, it's strange, but you might not catch that through something else. So that's exactly the kind of thing we want to look for. Cool. That's another question as well.
So did you look at your evaluation by yourself, or you have a program who look at it?
So typically we'll have it run with a program, and that'll kind of generate responses. And then what you end up with is you kind of see, if you can see up here, we've got these kind of rolled up metrics that we can see from there. And then that'll also look at a sort of more micro level if you go into these. And so typically what will happen is we'll run the evaluation ourselves, and then we'll actually use like a roll up piece here to kind of go in and look more manually once that's been kind of collected for you. Does that answer your question?
Yeah.
Okay, awesome. And I'll just show that this is like one way that we can kind of filter out to just the kind of certain spans that we care about to zoom in and pay attention from there. Everything that I'm doing in the UI is also, you can do programmatically, and we have people doing that in a lot of real cases. It's like automatically exporting the failure cases to go look at it in more detail. But yeah. Other questions? Yeah. Yeah, that's a great question. See if I can jump over to my connector. I defined it when I actually set up the Pinecone destination. So there's a piece within Airbyte here where I just said to use OpenAI ADA here, and so I added those in there. And then my Pinecone side also has its own sort of, or actually, the LangChain agent I have is also set up to then generate the embedding itself. So those were kind of done separately in the two different pieces. But this was really easy. So thank you, Airbyte folks. That was a really easy way to do it. Awesome. All right. Well, I appreciate all the attention from everybody. Really quick thank you for all of that. All my contact info is on there as well. If anyone would like to connect, I'll hang out for a while and happy to go into more detail on what we walk through. If anyone really likes Phoenix and has been using it, please also give us a star. We don't have any kind of telemetry, ironically, in our open source software. So this is kind of our way of knowing that it's resonating with people. So please give us a star if you can. Thank you.
All right, everybody. So that concludes our talks for the evening. As mentioned, you can still hang out. There's food, drinks. We're actually going to close shop until 8 o'clock. If you want to go ahead and learn more about Phoenix, also at the front, there is these 2 QR codes right under the logo for the event. One of those will lead you to the site. So I encourage you to scan that as well. And you can also scan to learn more about Airbyte 1.0, our big launch coming out in a few weeks. But thank you all very much, and looking forward to seeing you at more events. Enjoy tonight.